Hello everybody and welcome to the MLittleProgramming tutorial. In today's video we're going to be looking at functions in Python, what functions in Python are, how to use functions in Python, and when to use functions in Python. And then later in the video we will look at what recursion is, where we can use recursion, and how we can replace for loops and while loops in our Python code. Please like the video and subscribe to the channel if you want to see more of this type of content. Let's jump straight into it. So what is a function? A function is a block of code which runs when we call it from somewhere else in our code. You can pass in data, known as parameters or arguments, into a function. A function in Python may or may not return data as a result, and we'll get into what happens in a function when we don't specify a return value later on in the video. Let's get into how we define a function in Python, so let's jump into pycharm. To indicate to Python that we're about to define a function, we use the keyword def. After a space we define the name of our variable. We're going to keep it super simple right out the blocks and just call our function as my_function. We then add parentheses to the end of the function name to tell Python that we can call this function. When we get more advanced with these functions in a moment, you'll see that this is where we can pass parameters into a function between these parentheses. Finally, to tell Python that we have finished declaring our function, we place a colon. With this basic example, I want to give you a bit more information about some of the Python specific details that functions have. So first up, in other languages like Java and Scala, we have to define what the return type of a function is within the function declaration. So if we knew this function we're defining is going to return an integer, we need to tell those languages that in the declaration statement. In Python, this is not needed. You may have noticed the way we name this function my_function. Python has a few naming conventions for functions, like with variables. The naming convention for a Python function is that all letters should be lowercase, and each individual word in a function should be separated by an underscore. These naming conventions are designed to both improve readability of Python code, but also so that every Python programmer is styling their code in a similar way so that it can be picked up easily by other developers in the Python community. Now we've gone over a few interesting facts about declaring a function in Python, let's get into the body of a function. So after our colon, it's similar to what we looked at with Python loops. After the colon we press enter, and then we follow the Python indentation rule of 4 spaces. This is where we define the body of our Python function. For this first example, we're just going to do the most basic task, and that is to print a string. So we're going to print MLittleProgramming. So now we have a function that we can call, and that will do something when we call it, print MLittleProgramming. So how do we call a function in Python? We can call a function from anywhere else in this file, after the function definition. I'll show you what I mean by that in a moment. To call in a function in Python, we essentially type this part of our function, so the name of the function, followed by parentheses. So if we run this file, we see MLittleProgramming printed. What I mean by we can call functions anywhere after the function is defined is that currently we are calling the function after it's been defined. However, if we move this function call above where the function is defined and run the program, we get this error. The error is that Python doesn't think that this function has been defined. This is because our function hasn't been defined yet in the program's runtime, as the function definition is below where we are calling it. So now we've got the basics of functions, let's make our function a bit more complex. Let's add an argument to our function. Before we do that, you may hear other people in the software development community throwing words about like parameters and arguments. Both of these words seem to refer to the same meaning. Maybe surprisingly, they actually don't. Let's clear the difference up. The difference between these two terms is best explained from the function's perspective. A parameter is the variable listed inside the parentheses in the function definition, whereas an argument is the value that is sent to the function when it is called. So we're calling this function here currently with no arguments. This is because we're sending no value to the function in the parentheses. This also means our function has no parameters because we haven't defined a variable in this function definition. Now let's make our function a bit more complex and add a parameter to our function definition. A parameter definition follows the same rule as when we define a variable. Now this can obviously cause some issues if you're not aware of them. Let's see them in action first by defining a parameter called param. Inside our function, instead of printing MLittleProgramming, we're going to print our param, or whatever we pass into the function. So now if we come down to where our function is called, we can pass in data, which is our argument. We're initially going to pass in the string MLittleProgramming, so this program will have the same functionality as before. So when we run this now, we'll see that MLittleProgramming is printed again. However, as I just mentioned, some problems can arise with passing arguments into a function in Python. Python is a dynamically typed language, which means variable types, therefore parameter types, are calculated at runtime. What this means in terms of Python functions is that we can actually call our function here with any type we want at different points in our program. So to show this, if we call our function again underneath where we were calling it initially, but this time with an integer, so we'll pass in 36 as our argument. When we run this, what you'll see is that there are two lines printed, MLittleProgramming and the number 36. This is because our function does not care what type we are passing into it, which is something to keep in mind when you're designing your functions. Now let's talk a bit more about arguments. One situation where we can get an error with arguments is if we pass a different amount of arguments into a function than we have parameters. So in this example, if we pass two arguments into our function, for example, passing both our string MLittleProgramming and an integer 36 in the same call, we'll get an error. This error is saying that the function was expecting to receive one argument, but we gave it two. Although what if we don't know how many arguments we're going to pass into a function? Python has a solution for this. These are called arbitrary arguments. So if you don't know how many arguments your function is going to be sent, then you can add an asterisk before a parameter. So if we add an asterisk before our parameter, param, and run our program again, we see that our two arguments have been put into a tuple by Python. We can access each one of these items in the tuple we are given in the same way as we access items in a list. So if we want the first item, the string MLittleProgramming, in our print statement we add square brackets to the end of the parameters and pass in the first item index, which is 0. So if we run that again, all that's printed is the first item, MLittleProgramming. You may also have the problem where you don't know what order your arguments are going to be sent in. To solve this, we can use what are called keyword arguments. Keyword arguments use the key equals value syntax. To demonstrate this, we'll pass our arguments in with keywords. So the keyword for MLittleProgramming is going to be name, so our argument is name equals MLittleProgramming. And the argument now for the number 36 is going to be number equals 36. So back up in our function, we need to access these values. To access these values, we actually need to increase the amount of parameters we are telling this function it should expect. To do that, like with arguments, we just separate each individual parameter with a comma. We also need to change the name of the parameters. The name of the parameters have to be the same as the keywords we are calling them. So we're going to have the parameters number and name. The key feature of keyword parameters is that it doesn't matter what order we pass arguments in to the function. So in this case, we're passing the arguments in the order name followed by number, but the function is going to receive them in the order number followed by name. Now if we print name and run the program, we see that Python prints the name MLittleProgramming. So now we've seen arbitrary arguments and keyword arguments. There is actually a way to combine these two argument types. These are not surprisingly called arbitrary keyword arguments. With arbitrary keyword arguments, we don't have to know how many arguments are going to be sent or what order the arguments are going to be sent to a function. So we can actually go back to using just one parameter. To tell Python we are going to use arbitrary keyword arguments, we place two asterisks before our parameter. The way we call an arbitrary keyword argument, as opposed to just a keyword argument, is that here instead of referencing the key of the data we're trying to access, we pass the key as an index into square brackets. So in this case, to have the same functionality as before, we reference our parameter and simply pass the key name as the index. So we'll pass in the string name to print MLittleProgramming. So if we run that now, we'll see that the functionality has been preserved and we have printed MLittleProgramming. We have now covered arguments and parameters in Python functions. Let's now move on to returning from a Python function. Functions in Python do not have to return a value. When a return value is not specified, the function will automatically return none. Python functions, as we have seen so far in this video, do not even need a return statement. However, if we do want to return a value from a Python function, we generally want to go to the end of our function and write the keyword return followed by the value we want to return. So for an example, we're going to return double our number parameter. So to do this, next to the word return, we're going to access our number with the arbitrary keyword argument syntax and times that by 2. To output what is returned from the function, we can just print our call to the function. As you can see, for our example, when we run this, we print the value 72. And that just about wraps up functions in Python. We're now going to move on to recursive functions in Python. So, what is recursion? Recursion in computer science is a method of solving a problem where the solution depends on solutions to smaller instances of the same problem. Simply put, recursion is a function that calls itself. We can think of this like a Russian doll. You keep opening up the doll over and over again, each time finding a smaller doll inside. This process happens over and over again until there is the smallest possible doll with no other dolls inside, ending the process. Recursive functions have some requirements, often referred to as the 3 laws of recursion. The first is that it must have a base case. A base case is the termination point for the function. This is required because without a base case, theoretically, the function could continue calling itself forever. Second, a recursive function must change its state. This change in state must move the function toward the base case. This essentially means that a recursive function must have a parameter, so that our function could call itself with an argument that moves it closer to its base case. Thirdly, and an obvious result of the previous 2 laws of recursion, is that our recursive function must call itself. Recursion, like all programming paradigms, has some benefits and some drawbacks. We'll take the benefits first. Many algorithms can be expressed more elegantly using recursion. This makes your code easier to read by other people, which is important if you're working on a project in a big team. Recursion can also reduce the time complexity of an algorithm. This is because recursion by nature has decision-making control structures built in. This is because a requirement of a recursive function is that it has a base case asking whether the function should call itself again or terminate. However, there are a few drawbacks of using recursion. As I mentioned earlier, recursion can replace logical operators in our code. But recursion can sometimes be slower in its calculations due to the fact the processor has the overhead of maintaining a stack. A new stack is created for every function call, which is a greater overhead than the existing logical operators have. This means that recursion usually uses more memory for the stack than the existing logical operators. With recursion, it is possible to replace anything you write with a for loop or a while loop with a recursive function. Anyway, that's enough of what recursion is. Now let's get on to some examples. A real-life math example is 5 factorial. Don't worry if you don't know what factorial is, I'll explain as we go along. 5 factorial is written 5 exclamation mark. The factorial is all numbers multiplied together between 0 and the number we are finding the factorial of, not including 0. So in the case of 5 factorial, we would times 1, times 2, times 3, times 4, times 5. And so 5 factorial is 120. So if we look at 4 factorial, that is 1 times 2 times 3 times 4, which is 24. There is also a somewhat potential unexpected case if you are new to this, and that is 0 factorial. 0 factorial is 1. There is no need to go into detail about this in this video. It was mainly for the purpose of explaining how to write a recursive function so that we can work out factorials in the next example. So now we're going to hop into pycharm to write a function that can work out the factorial of a number that we pass into it. But first though, let's create a program that can work out the factorial of a number using a while loop inside a function. This is so that we can see how we can build a recursive function like an iterative program. If you want to learn more about while loops, I'll put a link in the top right now and a link down in the description. We're going to call our function getFactorial. Our function will have one parameter. This will be the number we want to find the factorial of. We'll call our parameter num. Inside this function, we're going to add 2 if statements. These if statements are going to apply those rules we know factorials follow. The first if statement is if the number we pass in is less than 0. If the number we pass in is less than 0, we're going to return an error, which is that we can't find the factorial of a negative number. The second is that if the number we pass in is 0 or 1, we know the factorial is going to be 1, so it's more efficient to stop the function here before we enter the while loop. Next, we're going to create a variable that's going to be called factorial, which we're going to initialize to 1. That will be the value we're going to keep track of what the factorial is of the number we pass in. Now we need to set up the while loop to actually work out the factorial of the value we pass into the function. In the while loop, we are going to check if the num is greater than 0. This is because inside the while loop, eventually we're going to decrease our num by 1 on every iteration. First though, we're going to multiply the factorial variable by our num on every iteration. To do this, we can use a similar syntax to how we increment numbers by 1 in a loop, but instead of the add symbol, we use the multiply symbol. Underneath this is where we're going to decrease our num by 1. I'll add a print statement so that we can see what's going on. So when we run this now, what we see is that on every iteration of our while loop, our num decreases by 1, and we times that with the value of the previous equation. This means that we are feeding a value that was calculated in the previous iteration as input into the next iteration of the while loop. This sounds like the description of recursion. We're breaking down our problem into smaller problems on every iteration, although here we're using a while loop, so this is not a recursive function.
So I mentioned earlier that we can rewrite any piece of code that uses an iterative loop with a recursive function. Let's comment this first function we've written out and replace it with a new function. The function will have the same parameters, just the number we want to find the factorial of. Underneath that, our recursive function will have the same if statements as we did with the while loop solution to increase our efficiency. However, instead of our while loop, this time we'll have a catch-all else statement where the recursive magic is going to happen. This means that our second if statement is actually going to have to change to an else if statement. Back in the else part of our if statement, we're eventually going to want to return the value of our factorial. So we place a return statement in our else. In the return statement is where we're going to do the recursion. So, like in the while loop, we're going to want to multiply our number that we pass into the function by our running factorial counter. So, in our while loop equivalent, that was num multiplied by factorial, our running counter for the value that we were going to return as the result of the value of the factorial. Similarly, in this case, we're going to times our num value by a value that's keeping track of our factorial value. In this case though, that value is going to be a recursive function call, so we're actually going to ask the function to call itself here. However, the value we pass in as an argument is going to be the number we passed in originally, minus 1. We'll run that as before. What we see now is that this has the same result as the while loop version of this program. So what is happening in this recursive function? What is happening is this num value will decrease by 1 on every recursive function call, like in the while loop where num was decreasing by 1 on every iteration of the while loop. That value is being multiplied by the factorial of the number 1 less than it. So in the first case, the calculation is 5 times the factorial of 4. The factorial of 4 is 24, so this results in 120. In the second case, we passed in 5 minus 1 here, so the calculation is 4 times the factorial of 3, so 6, making 24. The program continues in this fashion until num gets to 0 and then the program stops. This is one way to write a recursive function in Python. There is actually a second way, as I mentioned at the start of the video. Some people find this method of writing recursive functions easier to understand when they're just starting to write their own recursive functions. I know I did when I just got the grips with writing my own recursive functions. This involves writing what are called auxiliary functions. Writing an auxiliary function is an additional function that we write, meaning our recursive function is actually two functions working together. Let's use this factorial use case that we've been using so far for the other example in this video, so that we can see a direct comparison between the two. An auxiliary function is useful when our recursive function requires extra parameters than what we passed into the initial function call. For example, in our factorials function, there comes a point where the numbers we're trying to calculate the factorial of take a long time to calculate. This means that the user of the program may think that the program is not working, so what we can do is inform them that the program is working by printing something such as loading. We are going to move the functionality from getFactorial to a new function called getFactorialArgs. GetFactorial will still have the same parameters as we had before, as we are just going to pass in the number we want to find the factorial of. Inside the getFactorial function, we are going to have a variable, printLoading, which will initialize to false. After that, we'll have an if statement that says if the number we want to find the factorial of set printLoading to true. Under that, from this function, we're going to return getFactorialArgs. We're going to pass in the arguments of the number we want to find the factorial of, and the printLoading variable to the getFactorialArgs function. From this point, our program works the same way as the previous singular recursive function. The only code left to write is to get this recursive function to print loading upon every iteration. To do that, we can write a very simple if statement, if printLoading, then print the string loading. Now when we call the function, we'll call it with the value 300, so we can see our loading functionality in action. So when we run this now, we'll see that the program will print a series of loading statements, and then when it is done, it will print the factorial number as before. The benefit of this method of writing recursive functions is that we can add more parameters to the function that's doing the recursion than the one we pass in the initial call. They work in a very similar way to singular recursive functions. We go from the call to this getFactorial function. Then we call our args, which does some recursion, and then returns a final calculation to our getFactorial function, which in turn returns a value to the place we initially called from. So hopefully that made a lot of sense, and now you can start writing your own recursive functions. Thank you for watching the video this far. I hope you got a lot of value from it. If you'd like to see more Python programming tutorials, there will be a link in the description down below to a playlist of Python programming tutorials. With that said, if you liked the video, if you could drop a like on the video, it would be much appreciated as it really helps the channel, and subscribe to see new Python programming tutorials every week. Also, if you've got any questions about the video, drop a comment down below and I'll get back to you. Have a great day.